Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Infrastructure Thought Leaders series, Engineering Facades with Masonry and Breeze Blocks. My name is Amanda Rogers and I will be your host for today. Firstly, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that tonight's seminar is being hosted with our industry partner, Austral Masonry. Austral Masonry is one of Australia's largest manufacturers of concrete masonry blocks, retaining walls, pavers and stone products. Their residential solutions can be seen on high-end architectural projects and landscaping designs, while their commercial solutions include coloured and standard masonry blocks, large-scale segmental block retaining wall products, as well as a range of heart-stand solutions, such as commercial and permeable segmental block paving. They offer innovative solutions that provide structural integrity, excellent strength, durability, and pride themselves on making beautiful products that last forever. Please enjoy a short video from our partner.
Throughout the past 110 years, the face of building materials has continued to evolve. We're here for a lifetime of living. This is Brickworks. More than brick, and more than just building products, we are a foundation for today's lifestyle and a leader for today's style. We manufacture a wide range of building products. Products like no other. Local and international innovation. Sourced from around the world to exceed customer expectations. Distinctive and luxurious products. Beautiful products that stand the test of time. Building inspiration and innovation with an unmatched standing of style. This is Brickworks.
I'd like to welcome our speaker for today, Dr. Tathea Zara. Dr. Zara is a lecturer in the School of Civil and Environmental Engineering at Queensland University of Technology and has a vision to promote innovative engineering materials in construction. Tathea has 7 years of research experience in structural masonry and high energy absorbing materials. She has been investigating the performance of various types of masonry, including reinforced masonry, interlocking mortarless masonry, and brick masonry under various loading conditions. Tathea's research in these areas has shown that masonry has potential as a sustainable and resilient construction material, with less carbon emissions, better fire resistance, and offers ornamental designs in building facades. Tathea is a member of a Standards Australia committee to outline the design guidelines for mortarless masonry. She is also working in a new genre, high energy absorbing composites, that can provide protection and enhance the performance of masonry and concrete structures under impact and various other load conditions. Please welcome Dr. Tathea Zara.
Greetings everyone, this is Dr. Tathea Zahara. I am lecturer in the School of Civil and Environmental Engineering from Queensland University of Technology, QUT. I am lecturer here for about 2 years. I completed my PhD in the area of mortarless masonry, which is also known as dry stack masonry as a synonym. And this kind of masonry can be built without any mortar layers. Today I'm going to talk about design considerations for using block masonry in buildings. Before I start, I would like to acknowledge the traditional owners. The Queensland University of Technology, QUT, acknowledges the Turrbal and Yagara as the First Nation owners of the lands where QUT now stands. We pay respect to their elders, lores, customs, and creation spirits. We recognize that these lands have always been placing of teaching, research, and learning. QUT acknowledges the important role Aboriginal and Torres Strait Islander people play within the QUT community. A brief background of myself. I started my career as a design engineer in AA Associates, which is a consulting engineers firm in Pakistan. I worked there for about 3 to 4 years, and primarily I was working on designing of bridges at that time. Then there is a break in my career for taking care of my family. In 2007, I joined as a lecturer in civil engineering in Sir Syed University of Karachi, Pakistan, from 2007 to 2011. And after that, I switched to NED University of Engineering and Technology. I was serving there for 2 years as a senior lecturer, and primarily I am graduated in civil engineering from the same university. In 2014, I got an opportunity to pursue my PhD in the area of masonry, specifically dry stack masonry from QUT. So I completed my PhD from QUT in 2017. Since then, I am working as a lecturer in the School of Civil and Environmental Engineering from 2018 till present. The outline of my presentation today is basically consists of 3 phases. In the first stage, I will introduce what is block masonry and why block masonry should be preferred as comparison to other types of masonry or other materials of construction. In the second stage, I will talk about the structural aspects of block masonry and what are the challenges and design considerations for using block masonry in buildings. So I will talk about the structural applications of block masonry, and further we will discuss the design considerations for structural applications of block masonry. In the third stage, I will take up on the non-structural applications of block masonry, which will include the discussion on the usage of breeze blocks in facades specifically. So I would like to discuss with you the design aspects for masonry facades and what are the challenges to overcome using these blocks in the masonry facades or the facades of the buildings. Finally, I will conclude my presentation by showing you some real-world examples of buildings which have employed block masonry as structural and non-structural components. So let's start with why block masonry. Block masonry is comparatively new as compared to brick masonry, which is ancient, and brick masonry is being used for centuries in the buildings. So you might have seen many heritage buildings in Australia and around the world, which is made of unreinforced brick masonry. Block masonry, in comparison, is quite new. It has been developed actually with quality control manufacturing of blocks a few decades ago. And as you can see in this figure, block masonry is mainly consists of concrete blocks which are made hollow purposely. And the benefits it can offer is that less mortar is utilized as compared to brick masonry and other forms of masonry. It also offers the use of large size of blocks, as you can see in this image. The common block size which are available in the market in Australia are 390 millimeter long, 190 millimeter thick, and the height of these blocks is usually 190 millimeter. So these, in comparison to bricks, are much bigger blocks. Brick is usually only 230 millimeter long, 76 millimeter high, and 110 millimeter thick. So because of large size of blocks, um, you will need less number of blocks to create a same size of wall, which one can make in brick masonry. Secondly, as you can see, these blocks are usually hollow and they have hollow cores in the middle of them. So these hollow cores are arranged in different patterns and different kind of blocks. And the purpose of these hollow cores, firstly, is to reduce the self weight of the blocks, to reduce the weight, and secondly is to provide reinforcement and grouting. So this aspect of block masonry actually enables this block masonry, this kind of concrete block masonry, to be earthquake resistant as well as wind resistant. So these cores can be reinforced as shown in this image, and the cores can be grouted. Sometimes, if reinforcement is not needed, the grouting can be done alone. And from my recent research, I discovered that grout is a major role play for controlling the strength of the block masonry. And I discovered that a 50 to 60% increase in the block masonry strength with grout. Due to these significant properties of block masonry, it can be used as a structural component in building as well as non-structural component in building. And both of these components provide excellent acoustic resistance as well as insulation from heat and sound. So this is a brief introduction of block masonry and what actually benefits it can offer in comparison to other building materials. Now, the structural applications of block masonry, how it can be used. So the structural applications, like other materials, including concrete, steel, and timber, block masonry can be employed in any kind of buildings. Okay, so it can be used for residential buildings, in housing, and in apartment buildings, commercial buildings, such as shown in here, or medium to high-rise buildings. So I'm going to show these real-life building examples later in my presentation. So the idea of employing block masonry as a structural element, so it is supposed to carry two different loads. First, gravity loads, which are caused by structural elements themselves and other imposed loads. And secondly, the lateral loads, which are caused by earthquake, wind pressure, and in some cases by retaining earth. So as an structural element, masonry is used as load-bearing walls, and these load-bearing walls should be able to withstand the combination of these loads, the most critical combination as described by the relevant standards. So now I'm going to talk about these design aspects so the masonry can withstand these loads. What are the design considerations? So briefly, I will describe the design steps or the design philosophy of masonry buildings. Like any other building, the first step would be to assign gravity loads. So this step is usually used the regional area codes for any building. So this is at the building level, this step, and the gravity loads are assigned to the local codes and the usage of the building. In the second step, usually the fire and durability considerations are taken into account, and then the preliminary sizing is carried out. So preliminary sizing means basically the thicknesses of the masonry walls are decided based on the fire and durability requirements. So I'm going to discuss about the fire and durability design later in my presentation. Once the designer gets the preliminary sizes and the assigned gravity loads, a detailed gravity and lateral load analysis is carried out. And basically, it can be done through softwares, and it can for low-rise buildings, it can be done by longhand calculations as well. So gravity loads are distributed on each wall based on their tributary areas of the floors or the slabs. Similarly, the lateral load analysis is carried out to compute the earthquake loading on the masonry building, wind loading on the masonry building, and finally, these loads are combined to find the most critical load combination, and that the most critical load is then distributed. So these three steps are carried out at the building level, and then these critical loads are distributed on individual walls. So this is local or detailed analysis of the walls themselves. So the loads combination, which are the combination of gravity and lateral loads, earthquake or wind, are distributed to find out the most critical compression force, tension force, in-plane shear, and out-of-plane bending and shear on the masonry walls. So once we get the forces which are acting on each masonry wall, then the individual walls are designed to carry these loads. So designing means the decision on the masonry strength is made. Masonry strength is in turn dependent on the type of blocks to be used as well as the mortar grade. So I will discuss about the mortar grades later, what kind of mortar grades are allowed to be used with block masonry. And then at this stage, the grout strength is decided if the masonry has to be grouted to increase the strength. Reinforcement diameters and spacings are calculated, and the connections between the non-structural and structural parts of the building are also designed. So this is a brief, basically how the masonry buildings are to be designed. Now the Australian standard to be used for designing of the walls to withstand these loads and other durability and fire concerns is the Australian Standards for Masonry Structures, which is AS 3700, and the recent version was released in 2018. This code provides provisions for the design of structural masonry, which can be unreinforced masonry of block or bricks, and reinforced masonry, commonly known as URM for unreinforced and RM for reinforced. And the code provides the design provisions for durability design to resist the environmental effects on the masonry buildings, fire designs for resistance against the fire spread and insulation, serviceability aspects to resist the cracking, deflection, and movements in any masonry building. Now, the strength is aspects, of course, to provide resistance against the design loads, whether it is compression, in plane shear, and out of plane loads. And finally, the stability aspects of any building to resist overturning, uplift, and sliding. So this is a brief of this code, and now I'm going to discuss individually the design guidelines for fire, durability, serviceability, and strength. So starting with fire design of the masonry walls or masonry buildings can be carried out using section 6 of AS 3700. So this section will provide the structural requirement for masonry walls based on the desired fire resistance level. So as you might know that fire resistance level is determined from the National Code of Construction, and the recent version is 2019 version based on the construction type and the building type. Once we know the fire resistance level or fire resistance period, this code provides the provisions for a structural adequacy. For masonry wall to be structurally adequate during the fire event, it is usually controlled by the slenderness ratio of the buildings. So as one can imagine, in the event of fire, the masonry surfaces can be deteriorate and can change the thickness of the walls. So in the event of fire, if the wall thickness changes, then the slenderness can be increased, because slenderness is nothing but the ratio of height to thickness of the wall. So because of the spalling of face shells or any other damage due to fire, the slenderness is restricted, and for reinforced masonry walls, it is restricted to 36, while for unreinforced masonry walls, it can vary from 15 to 25 depending on FRL. The second aspect for fire design is insulation, and for making sure that building is insulated for a given fire resistance period, minimum wall thicknesses are specified in section 6. So minimum wall thickness, if the engineer encounter taken into account, then the building will be safe for the given fire resistance level. To increase the fire resistance period, grouting can be done in block masonry, so it will provide better insulation. The third aspect of fire design is integrity, and integrity of masonry walls is usually considered fulfilled if it is properly designed for structural adequacy and insulation. So this was about the fire design of the block masonry walls. Now the serviceability. Serviceability can be designed using section 2.5 of AS 3700, and serviceable block masonry will be considered safe against cracking, deflection, and movements. So maximum allowable crack width is given in the code as 1 millimeter, but sometimes it can be 0 because of the aesthetical requirements of any building. Deflection limits are usually provided for the masonry beams only because they can deflect. Otherwise, for walls, there are no deflection limits prescribed in the code. However, this code provides the deflection limits for the adjoining members or the supporting members so that they don't deflect excessively to avoid damage to the joining masonry. The third aspect of serviceability, so this code says for masonry building to be serviceable, robustness design should be carried out. And for carrying out the robustness design, a minimum of 0.5 kPa out of plane pressure is considered on the surface of the wall. And then it is made sure by designing it that this pressure can be resisted by the wall. So throughout the life cycle of the wall during construction as well as during the design life. Finally, masonry walls are provided with the joints such as control joints, expansion joints, and articulation joints. So these joints are to provide expansion and contraction for temperature changes, for construction, as well as to avoid movements which are caused in slabs or in foundations or differential settlement of soil. So that movement can damage the masonry. So these joints are important in masonry construction to avoid damage to the walls. Now the third design aspect is durability. 5 of AS 3700 covers this aspect of block masonry. So durability is important to avoid the environmental effects on the surface of the masonry. So block grades can be chosen to avoid the extreme environments accordingly with AS 3700. And there is another code, AS 4456, which specify the block testing details and block grade details for different purposes. Mortar grades are in Australian standard. There are 4 mortar grades. However, for block masonry, only structural mortar grades, which are M3 and M4, high strength mortars are allowed. Low strength mortar grades are not allowed to be used for block masonry for durability concerns. Grout properties are also included in the code. So it can give the mixed design ideas and as well as the minimum grout strength, which is limited, which cannot be lower than 12 megapascal for strength and durability concern. Then the reinforcement and tendon properties are also included in the code, and additional details can be taken from AS 4671. Cover to the reinforcement is also specified in AS 3700 to avoid corrosion of the reinforcement. Damp-proof course requirements are also included in the section 5, and more detailed requirements for masonry buildings are included in Australian standards 2904. So damp-proof coursing is required for water ingress and water tightening design. So it will resist the water accumulation in the masonry walls, and it will resist the deterioration in the surface of the walls, which can be caused by water. So these are the fire serviceability and durability aspects. Now the strength aspects. For strength design, firstly, I would like to discuss the compression design. Compression design is separate for unreinforced masonry and reinforced masonry. So Section 7 of the code, AS 3700, covers the specifications for unreinforced masonry for compression, shear, and bending. And Section 8 of the code covers the reinforced masonry design. So I cannot discuss the design equations. However, I'm going to discuss the factors on which the masonry compression strength or shear strength will be dependent on. So this figure shows a typical block masonry, and as you can see, these are the elements of block masonry. So the prime factor which affects the compression design of the masonry walls is the masonry characteristic strength of masonry, F-M, which in turn depends on the type of blocks being used in the walls and the mortar grade. So as I told you, only high strength mortar grades are allowed to be used with block masonry. And in addition to blocks and mortar, which defines the masonry strength, mortar bedding is also important, mortar bedding area. So typically for block masonry, only face shell bedding is used. It means on the faces only the mortar layers are applied. So here you can see on the vertical joints also, the mortar thickness is only restricted to face shells, and the whole web is not used for bedding the mortar. So mortar bedding area is important, and specifically the face shell area for compression strength. If the block masonry is being grouted, then of course the grout strength will play a role in the compression design, and the grout area as well, which is area of the cores. Then another important parameter is the vertical bars, vertical reinforcement. If the masonry has to resist the earthquake loads, and if the height of the building is more, then the vertical bars have to be included to increase the strength of the building. And vertical bars are to be tied in both directions as per the code requirements. There is another requirement that the bars should be centrically placed to provide sufficient bond with the grout. Slenderness and eccentricity of the load are also taken care of in both of these sections. So as the slenderness increases, the compression strength of the wall will decrease, of course. So there are reduction factors to account for slenderness as well as for the eccentricity of the loads. Now the in-plane shear design is covered in these sections of the code. And shear is primarily caused by earthquakes in masonry buildings. Usually wind is not critical, but anyway the designers should check the buildings for earthquake as well as for wind loading. So in-plane shear is caused by earthquake in most of the masonry buildings. So for unreinforced masonry, the in-plane shear resistance is mainly governed by the shear bond strength. Because there is no reinforcement in the unreinforced masonry, then the sole shear resistance, in-plane shear, which acts from the side of the wall, will be resisted by the shear bond provided by the mortar on the surfaces of the blocks. So shear bond strength can be taken as maximum of 0.35 megapascal if the testing is not carried out, or it can be calculated by relation of flexural strength of masonry, which will be discussed in the next slide. Shear friction strength is also important. So the friction between the joints provide resistance against in-plane shear. So because of the low shear strength, you can see that unreinforced masonry can be critical to resist earthquake. However, if we use the vertical reinforcement, then the vertical reinforcement area and its anchorage with the slabs and the footings is important in resisting the in-plane shear. Masonry strength, of course, is again the major role for in-plane shear. And this code also checks the stability of the walls against rocking failure. So sometimes the aspect ratio play a major role in stability failure. So for certain aspect ratios, it is recommended to check stability of the walls against rocking failure. So this was about in-plane shear design of block masonry. Now moving on to out-of-plane bending design. Out-of-plane bending design is covered in section 7.4 for unreinforced masonry and section 8.6 for reinforced masonry. So out-of-plane bending is primarily critical in wind loads in masonry buildings, specifically if the building is in cyclonic region. So the wind loading will cause critical out-of-plane bending as compared to the earthquake loading. So for out-of-plane bending, masonry has a very low strength if it is not reinforced against out-of-plane bending because of the low tensile strength. So according to the standard, the characteristic tensile strength of masonry is only 0.2 megapascal. If it is not tested, then the maximum value is 0.2 megapascal. So because of this low number, one can imagine if there is no reinforcement in the masonry, then it is vulnerable to earthquakes. In history, we have seen the damage to masonry buildings, specifically brick masonry buildings, because brick masonry is usually solid masonry in which reinforcement is not provided. And in absence of reinforcement, um, the building will be vulnerable to out-of-plane bending and it can collapse. Um, on the other hand, if the building is reinforced masonry building, then the tensile reinforcement area and its effective depth can increase the bending strength of masonry. So this figure shows a wall which is tested in QUT. So you can see that these are the tensile bars. The vertical bars provide the resistance against tension, which is caused by earthquake in the building. So these bars area and their effective depth from the compression phase will be important to calculate the moment capacity of these walls, which is similar to reinforced concrete walls actually. And finally, the masonry strength is the most important factor for resisting out-of-plane bending. So these are some design tips or how, some considerations which a designer can undertake. So the bars should be in the center of the blocks. And the reason behind it that the vertical bars should have a grout annulus around them, which should not be less than 2 times the diameter of the bar to provide sufficient compression resistance and the bonding with the bars. Horizontal bars, as shown here, can be provided along with vertical bars. So these horizontal bars can take part in taking the in-plane shear as well as out-of-plane bending. Lastly, the out-of-plane shear design. So unreinforced masonry cannot take out-of-plane shear. So these out-of-plane shear design specifications are provided for reinforced masonry only. So unreinforced masonry, of course, will show very brittle failure for out-of-plane shear forces. For reinforced masonry, the shear strength of reinforced masonry for out-of-plane shear is considered as 0.35 megapascal. Tension reinforcement is taken into account in the design equation, as well as the horizontal reinforcement. And of course, the effective depth and the spacing of the bars are the main factors which taken into account for calculating the out-of-plane shear capacity of the reinforced masonry block walls. So these are the main design considerations for masonry, strength and stability wise. Now I will move on to non-structural applications of block masonry. So in non-structural applications, masonry block walls can be used in certain aspects, such as infill walls. So infill walls are basically the walls in reinforced concrete buildings in which the main structural members are the beam column frames, and in between the beam column frames, masonry is used as infill walls. So this is very common kind of construction. Partition walls, in which the masonry walls is just used for partitioning of the rooms, the space. So it is non-structural component use of masonry. Then firewalls. So firewalls are common in steel buildings or wooden buildings in big buildings to provide fire insulation and resistance to fire, because masonry has good fire resistance as compared to steel and timber, of course. And finally, in facade. So facade application of block masonry is getting attention by the designers. And in this presentation, I will primarily focus on the facades which have used block masonry and how block masonry can be used in facade of buildings. Okay. Block masonry in facades. So for different heights of the building, the design implications will change for the masonry buildings. For low-rise buildings, such as housing or two-story buildings, its strength may not be a problem for facades because the lateral loads will be will not be very critical in low-rise buildings. However, durability aspect will be much more important for low-rise buildings. On the other hand, so this figure is taken from brickworks, and this house is made of block walls, as you can see. However, on the other hand, for medium to high-rise buildings, facades become more critical in earthquake and wind. So the facade panels, such as here, they have used breeze blocks in the facade, and these breeze blocks panels are non-structural, but they have to be designed to resist wind and earthquake pressure, out of plane earthquake and wind pressure. Secondly, their connections with the backing structure, with the structural components of the building are important. So they are usually supported by steel frames as shown in this image. So connection with the structural components, and then the durability aspect of the facades. Of course, I'm going to discuss these aspects now. Before I start on the design aspects of facade, I would just like to share what kind of blocks and products are available in the market which can be used in facades of buildings. So as I showed earlier, hollow core blocks with surface texture are widely available in the market, in which the face of the blocks is provided with texture for ornamental and decorative purposes. So these are just few examples there, but there are many more products available in the market. So split face blocks have, different textures such as limestone and other minerals such as granite, etc. So these come in different colors. Horn blocks with lines are very common. Smooth face blocks also come in different colors, so they are without any texture. And then veneer split face blocks. So these blocks were recently used in building in facade, so which I'm going to show you later in my presentation. So the aspect which is beneficial when using hollow core blocks in facade is that since these blocks can be grouted and reinforced, so they can be used as structural walls. On the same hand, they can fulfill the purpose of facade because they have beautiful textures. So I'm going to show some case studies and some real life buildings which have used these kind of blocks as the facade blocks as well as the structural walls to bear loads. Another product which is getting attention are perforated blocks with openings on the face, or otherwise known as breeze blocks. So breeze blocks have coming into attention after a long period of time. They were very common in 50s and 60s, but then their popularity died. In the meanwhile, they have picked up the attention of the designers again, and I'm going to show some real life buildings which have used breeze blocks beautifully in the buildings. So breeze blocks offered two benefits. One is that they have better fire resistance as compared to aluminum and timber, and secondly, they are aesthetically beautiful, and they provide shading from the sunlight. Okay, so I will show some real life examples. Now, the design considerations for block facades. What are the different design principles and the aspects which are important? So first of all, I would like to discuss the earthquake and wind resistance of the facade masonry block facades. And these design considerations are same for solid, hollow core blocks as well as for breeze blocks. So earthquake and wind caused in-plane and out-of-plane loads in facades, and these can be resisted. These should be resisted by the block panels. To properly design the facades or the block masonry panels against these loads, these two, flexural strength of masonry and the shear bond strengths are important. In case of where the masonry cannot be reinforced, such as in breeze blocks, then these strengths can be increased by employing polymer-based mortar. Secondly, the code specifies that robustness must be checked for all facade panels, whether it is solid or porous or hit and miss or breeze blocks. So, as I said earlier, robustness design includes to consider 0.5 kilopascal out-of-plane pressure on the surface of the walls or the panels, and they should be able to withstand this pressure. The facades should be supported on all four sides, or at least three sides. The top edge can be free. As shown is this in this figure, so you can see these buildings have employed breeze blocks in the facade, and you can see that all the breeze block panels are supported on all four sides. Okay, so this is important. This gives stability to the facade. Okay, sorry for that. So bond beams and engaged pairs can be included for the large panels to confine them. As in this example, you can see to avoid the higher length of the wall, to reduce the height of the panel, you can see that bond beams are provided in the middle of the frame of the panel. Similarly, these side walls here are providing the support. So engaged pairs sometimes can have larger thickness depending on the requirement. So these are called engaged pairs, and these are bond beams, and they provide strength to the masonry facade as well as they reduce their slenderness, and so is the vulnerability to collapse in earthquake or in wind scenarios. Okay, so it will reduce the slenderness effects and provide a strength. Another option or another design consideration is the bonded reinforcement between the joints of the panels and the supporting member. So if needed, sometimes the bonding reinforcement can be provided in terms of meshing or in terms of angle irons or flashing angles to support the masonry facade. And in some cases, column ties and head ties, so head ties and the column ties are utilized. So the column ties and head ties should be of sufficient strength and should be spaced properly according to AS 2699 standard to transfer the load effectively from the facade to the supporting structure. So these are all the design considerations which are important to make masonry facades to resist the out-of-plane pressures, specifically caused by earthquake and wind forces. Now I would like to discuss the durability aspects of masonry facades. So durability of concrete block masonry panels can be controlled by selecting different kind of blocks and mortar grades. So usually the texture blocks are low maintenance blocks because they provide excellent weathering protection. However, blocks should be selected and tested as per Australian standards 4456. So this code provides the specification for the testing of block strength, for testing it for the salt attacks, for finding the coefficient of expansions and coefficient of contraction for heat resistance. So this code can be used to test the blocks for these properties, and sometimes the manufacturers and designers and the distributors have these properties in hand, and they supply these properties to the designers. And after blocks, the second important aspect for facades is the mortar grade. So mortar grade is very important, and in the Australian standards, AS 3700, only M3 and M4 mortars are allowed for the block masonry to avoid mortar deterioration in exposed environment. In some cases, polymer or adhesive based mortar can be very durable and stronger. We have tested this mortar for thin bed masonry, and we found that this mortar provide a high shear and flexural bond strength as compared to the conventional mortar. Metal connectors is used to connect the masonry facade with the supporting members. So metal connectors should be embedded within the mortar bed or within the grout, and if possible, the block cores can be grouted so that these metal connectors should not be corroded from the environmental effects. Finally, in some scenarios, in extreme weather conditions, protective coatings can also be employed to protect the facades from the weathering actions. So these were the main durability and the strength considerations for masonry facades, whether they are made of the hollow blocks or they are made of breeze blocks. For all kind of blocks, these considerations are common. Now, this is the last stage of my presentation in which I am going to show some case studies or the real life examples of buildings which have employed block masonry in their designs. So I will start with housing in which is the low rise construction. So this, I have taken these pictures from the manufacturers, from the distributors of masonry in Australia. So this picture is taken from Boral Masonry. And you can see that in this house, they have used the smooth face concrete blocks as load bearing walls. And these blocks are also fulfilling the facade aspect of the building, and they are load bearing walls. They are resisting not only the loads, but they are also fulfilling the beautification and the ornamental aspects of this house. These two examples actually show the combination of the honed bricks, which are the hollow blocks, not the bricks, sorry, the blocks, honed blocks in the main load bearing walls of the buildings, and the column, as you can see here and in this picture, as well as the breeze blocks. So breeze blocks are used in these two houses here on the front face for providing privacy, and here on the side face of the building. So the combination of blocks can be employed to serve the purpose. And there is another image which I added just to show the application of breeze blocks in interior walls. So interior walls or partition walls can employ breeze blocks for beautification and partition purposes. So this type of masonry has huge potential for used as facades as well as inside of the buildings. Now moving on to low and medium rise buildings. So I would like to show this building, which is built in Gold Coast, Queensland, and this picture is taken from Brickworks. So you can see that this building comprised of the load-bearing masonry walls. Okay, so these are load-bearing masonry walls, and they have used split-face blocks. Okay, with a certain limestone texture. So the purpose of these blocks is to resist not only loads but also provide a beautiful facade for the building. Similarly, in this building, which is a commercial building, which is in Queensland again, they have used breeze blocks, and these are, of course, the non-structural aspect of masonry. So these breeze blocks are designed in panels, and this panel is supported on the steel frame. Okay, so these are steel columns, steel posts, and behind there is a frame of the steel members which are supporting this facade wall. And I would like to show in which the side walls and the front walls are made of breeze blocks, and all of these blocks are supported by thin tying members, as you can see on the top and on the sides of the walls. So this is another application of breeze blocks in the low-rise buildings. Now, I would like to include this building because it has pushed the boundary of designing. So this building is not in Australia. This is situated in Arizona. And in this building, this building is designed in such a way that it employs two shells of block masonry. There is an outer shell of block masonry, which you can see in this picture, and which is inclined and which shows the beautiful facade in slopes, okay, to give it a beautiful decorative face. And then there is another shell of concrete blocks which is inside the building, and these blocks are supported by the steel stud framing building. So steel stud framing or metal stud framing is the main component for taking loads, while the masonry blocks served for the facades. And the purpose of double shells is that the outer shell makes the masonry facade in on a decorative manner, while there is another shell of masonry walls. So there are double skin masonry walls which are supported by the metal stud framing. And the inner shells, as you can see, is provided with protrusions and folds, and these folds were designed to provide acoustic resistance and for distributing the sound inside the theater. So this is a performance theater, and the block masonry is used purposely for acoustic resistance and for distributing the sound and to make effects for the performance. So this is a boundary pushing application of block masonry in building. And there is another aspect which I would like to discuss is the slope of the wall. So every block of this, every course of this block wall is 15 millimeter eccentric from the bottom course. So this is really amazing how the designers are using block masonry for achieving a certain purpose. And this is a high-rise implication of using block masonry in any building. So this building is in Melbourne, which is recently refurbished and rehabilitated. So Collins Street, Melbourne. So this building has utilized split face blocks on the facade, and these block panels, vertical panels, are supported by the steel framing structure, and they are connected with the back structure which are taking the load of these blocks. So this is a beautiful application of split face blocks in high-rise buildings. And there is another important aspect of the blocks in. So inside this building, there is an atrium, which is catching atrium. As you can see, there is a feature wall, which is made of veneer split face blocks, and in combination with the honed blocks. So honed blocks are used for making the bond beams, while the split face blocks are arranged in such a manner that deliberately with some hit and miss type of bonding, and the purpose for irregular sized gaps was to make a pattern resembling a barcode. So this is a beautiful facade, atrium wall, which was built in 2018, recently in Australia, in Melbourne. So it is an amazing use of block masonry in high-rise buildings. This is in Queensland. So they have used breeze blocks in combination with hone blocks. So you can see these are hone blocks oriented in such a manner, and these are breeze blocks. So in combination, they make the panels of masonry blocks, and then they tied them with the frames behind these facade panels. So these frames are made of steel members to attach these facade panels with the backing building, and the load is transferred from the facades to the backing structure. So this building is situated in Brisbane, and you can see how beautiful is looking, providing protection from sun and privacy. This is another example, which is in Gold Coast. So this is in south wall of an stadium, Velodrome Stadium, which was actually built for the Commonwealth Games about 2 years back. And in this wall, you can see they have used plain-faced concrete blocks, and they have deliberately oriented some of the blocks in this way to give it a pattern of bike wheel. So these are, some examples which are in Australia and which can amaze designers that how block masonry can be employed in different ways to provide a beautiful ornamental facades and decorative walls within the buildings. This is my last building example or the case study of high-rise building, or maybe a medium-rise building, I would say. So this building is situated in Mexico City. It is called Apertures. It has a beautiful facade which is made of perforated masonry blocks, and they are enclosed in a curved steel frame to support the masonry facade. And you can see the shape is specifically provided to make a ship sail. So this is a beautiful application of using breeze block in facades of medium rise to high rise buildings. So you can see the facade is going all the way from bottom to top of the building. Is being supported on the steel frames on each floor level. So you can see these are the supporting frames to tie the facade with the backing structure. And in this particular building, they have designed the facades for gravity as well as for earthquake loads. So they have made sure that this facade wall can withstand the gravity, so its self-weight as well as the earthquake loading. And this is the closer picture of the breeze blocks, how they have arranged to give it a very aesthetically appealing surface. So these are boundary pushing ideas to use breeze blocks or conventional block masonry in building structures. So with this is the conclusion of my presentation. So I discussed how the block masonry can be used in structural and non-structural aspects of any building. I would like to acknowledge Queensland University of Technology for their support in teaching this unit at the university and for carrying out research in this area, in the area of masonry structures. I would also like to thank Concrete Masonry Association of Australia, CMAA, for their financial support for masonry research at KUT. And last but not the least, Engineers Australia and Brickworks for organizing this webinar and inviting me as a guest speaker. These are the references which were used in making this presentation. Thank you everyone for coming along and listening to my presentation. We will now head back to Amanda for the question and answer session.
Thank you, Dr. Tathir Zara, on a fantastic presentation. Thank you very much. So it's now your turn to get involved. So we'd like you to submit questions, and please do so by the YouTube chat box. Also, thank you to everybody who submitted questions on registration. And we've got quite a lot of questions coming through. We've got about 25 minutes, so I promise we'll get through as many as we can. Just want to kick off with a question from Markov in New South Wales, who's asking, Tathia, are we able to use waste materials to create useful and appealing blocks? Thank you.
Thanks, Amanda. Thanks, Amanda. Thank you for this question. So, in reality, I think University of South Australia is working on using waste materials in concrete blocks. I think up till now they have used rubberized, rubber powder to replace sand and aggregates in concrete blocks. So they have been quite successful. They have published many papers. And I have also seen their research where they have used water treatment sludge as sand in concrete to make blocks. So both of these waste materials, they have shown to work well, and the concrete strength is not compromised by adding these materials in as a sustainable, to make sustainable concrete blocks. Yeah, so I think research is going on, and in recent years, we will see many recycled concrete in masonry as well.
Question coming from Matt, who's in Victoria. Good evening, Matt. Matt's asking, can hit and miss brick walls be designed for two-way bending?
Oh, yes. So hit and miss masonry is common in brick mostly rather than in blocks. And hit and miss masonry can be designed for two-way bending. In fact, Assistant Professor Mark Macia is doing a lot of work from University of Newcastle in this area. And I have seen his papers in which he has tested hit and miss masonry, brick masonry in vertical bending and horizontal and two-way bending. And I think he has shown that two-way bending is capacity of hit and miss is much higher than vertical bending. So yes, it can be designed using the same provisions which are used for conventional brick masonry. Same provisions can be used.
Thank you for that. Thank you. We've had a great question come in from Don, who's talking about fired brickwork wall. Don's asking, how does the compressive strength of non-reinforced block masonry wall compare to a traditional kiln-fired brickwork wall?
Okay, thanks for this question. So in case where testing cannot be done, so Australian standards provide similar provisions for clay brick masonry as well as concrete block masonry. Um, so just for an example, if you have same strength of concrete clay brick and clay brick and concrete block, for example, 20 megapascal brick versus 20 megapascal concrete block. So according to standard, they both gives the same masonry strength. However, in Australian standard, there is a provision for height of the block to the thickness of joint ratio correction. So eventually, brick has less thick height as compared to concrete blocks. So the strength of concrete blocks masonry will be higher as compared to brick masonry, prism or wallet. So this is according to Australian standards.
Thank you, thank you. And sort of grouping a couple of questions together here, we have had a question around maximum height of masonry walls. And the question is, what is the maximum height of masonry walls that can be designed in a residential situation?
That's a good question. So actually, the height of walls are restricted for controlling the fire design, as I discussed in my webinar. That for a particular fire rating, the slenderness is restricted to control the design fire rating of any building. So if you're designing reinforced concrete wall, then it is 36. And for unreinforced masonry walls, it can be at least 15. Um, However, for compression, because there are not heavier loads in residential buildings, because the question is specific to residential houses, then I think from 15 to 30 or 36 will slenderness ratio, not the height. So the corresponding height will be, minimum height will be around 2,800 millimeters. So 2.8 meter minimum height. Maximum height in case of unreinforced masonry, and for reinforced masonry, it can be higher. So for unreinforced masonry, it can be around 2.8 meter.
Thanks, Tathir. Thank you. And we talk a lot about recycling, environmental, and a great question's being asked about, are recycled plastics used to reinforce masonry blocks during manufacture? And if so, how does it affect the properties of the blocks? That's a great question from.
Yeah, thank you, Dawn. It's very important to think about sustainability and environmental friendly construction materials. Specifically, concrete is not environmental friendly. However, in Australia, I haven't seen research going on plastic recycling in concrete, but I am aware of some research going on in Europe to replace sand and aggregates with recycling plastic, powder. So recently, one paper I have seen in which they have mentioned that by replacing 50% sand with recycled plastic powder, they achieved quite similar strength, which is expected of sand and conventional aggregates. So this is quite wonderful. It means that various kind of plastics can be used to develop, concrete blocks with recycled plastic as aggregates. I think it can be very sustainable. Thank
And that's wonderful to hear, because as we know, Tathir, that we do hear a lot, a lot of the resistance to those recycled products is concerns about strength and quality. So that's really great for us all to hear that. Um, we've had a question from Singh in Asia, he said. Talk about material specification and design approach of the new product will be handy. So he's asked, material specification and design approach of the new product will be handy.
Thank you for this question. So basically, here in Australia, it is very common that all the manufacturers, such as Austral Masonry and other big masonry supplier manufacturers, such as Boral Masonry, PGH Bricks, so they supply the material properties, heat resistance and durability, fire rating for their products. So here it is commonly available on their website. So they mention the compressive resistance as well as the fire rating period and other properties with their products. However, in Australia it's quite standardized, and I'm not sure which Asian countries he's asking this question. So here in Australia, manufacturers are they are quite organized, and they provide all the material properties for their products.
Thank you. You mentioned just then fire ratings, and we have had a question coming in saying, can you speak about fire rating details?
Yeah, thanks for your question. In my presentation, I discussed about the fire rating periods and fire rating design, actually, fire design of the masonry walls. So to find out the fire rating periods of fire rating periods are not given, should be decided based on the National Construction Code. So in Australia, we use NCC code, which is called National Construction Code in Australia, which is 2019 version is the newest version. So depending on the type of construction and type of building, the required fire rating period for the walls is mentioned in that code. And for residential buildings is from 90 minutes for insulation and structural integrity as well as structural adequacy. However, for commercial and parking buildings, it can reach up to 120 or 180 depending on the type of building and type of the environment. So for these fire ratings, Australian Masonry Design Standard provides the required slenderness and thickness of the walls to be considered so that they will be safe against these fire rating periods.
Yeah. Thank you. Thank you very much. Good evening to Michael. Michael's asking a question, can both masonry leaves be used to resist lateral loads for robustness in cavity brickwork?
Yeah, that's a good question. For cavity walls, usually cavity walls are very common in brick as compared to block masonry because blocks are usually quite thick themselves. However, if we talk about the conventional cavity brick walls, so for cavity, both of the leaves are considered as a structural. So they are connected through metallic ties, and through metallic ties, the load is transferred from the outer leaf to inner leaf if we talk about the out of plane resistance. So yes, I would say yes, that for cavity walls, both of the leaves will be structural. However, in veneer wall construction, the outer shell is non-structural. It is just there to cover the building. So it is just for facade, it's just like a facade. Yeah.
Robin has sent through a question asking, can we use fly ash blocks?
Yes, that's a good question because fly ash is another recycling material, and it is very commonly used to make recycled concrete blocks. And fly ash can replace cement as well as sand to some percentage. And I think I have seen papers in which they have replaced 15 to 25% of cement by fly ash, and it does not affect the strength adversely. So it is actually beneficial for durability, and it is and to the environment because we are recycling fly ash for making concrete blocks. So yes, it can be used, and it is being used actually.
Thank you. Thank you. And we've talked about breeze blocks this evening. Chad has asked, can breeze blocks prevent wind-driven rain, Tathea?
Yeah, that's a tricky question. So as you have seen that breeze blocks have perforation on their faces. So of course, because of perforation, they cannot be fully watertight. So of course, the wind-driven rain can ingress inside the building. So I would say they cannot resist the rain caused by winds completely. Yeah, so that could be that could be one aspect. However, breeze blocks are usually, that's why, used only in facades, so the main structure inside is safe from the rain.
Thank you for that, Tathea. Nadeem, good evening, has asked a question. Can they use reinforcement rather than designing beams in the panel?
Um, I I think they're asking about the facade panels. So yes, so if the reinforcement is provided, as I said, the slenderness ratio can be increased. It means the bond beam can be removed, but one has to be very careful with the allowable slenderness ratio. So the slenderness for fire rating should, if with reinforcement, should not be increased from 36. So if the reinforcement can be provided in panels, of course the bond beams can be removed to increase the height of the panel. Yeah, but it has to be carefully carried out by checking the slenderness, maximum slenderness.
Thank you, Tathea. You mentioned just a little earlier about facades. We've had a great question come in. How about the block masonry's impact resistant behaviour, especially when they are used as facades?
Yeah, that's a good question. So, actually, I am also involved in impact resistance research at QUT. So, QUT recently won a grant in which we won about $400,000 to test the masonry walls against impact. So the lab is developing a state of art testing facility at QUT. So hopefully we can test the masonry for realistic impact loads. But what I have seen from the research which has already been done, that unreinforced masonry is vulnerable to impacts, and it can damage, and the impactor can penetrate inside the masonry walls, and it can be seen very commonly because car crashes is very common around the world, and in Australia we have seen many car crashing inside the houses. So unreinforced masonry, of course, it is vulnerable to impact, and reinforcement can be provided, or protective rendering can be provided to resist the impact inside the masonry walls. Yeah, so that's a good question. So unreinforced masonry is not safe from impact.
Thank you. And we've had this question asked in a few different ways, and I'll use the one that's coming from Cameron. What is the life expectancy of block masonry, in your opinion, Tathea?
Yeah, and I would say from Australian standards. So, according to Australian standards, minimum design life, we for any concrete masonry building, we chose at least 50 years. So this is what, according to standards, we chose to design any masonry building. So this is supposed to be minimum design life. However, we have seen many masonry buildings surviving much longer than this life. So the minimum from Australian standard is 50 years, so at least it is supposed to survive 50 years.
Thank you. And thank you for these questions coming in thick and fast. We've had a question about the steel beam asking, can the steel beam be connected to a RM wall with anchor bolts?
Oh, that's a good question. um, so at the moment there are many renovations and rehabilitations going on with old masonry structures. So I have seen few examples in which they have anchored old masonry walls with the backing structure, which is made of steel. I'm not sure about a steel beam, but I have seen the anchoring being done with the steel columns. So this is very common. So masonry walls can be anchored with the steel columns. I haven't seen anything with steel beams, but I think for facade panels of masonry walls, it is doable because facade panels are not very heavily loaded, so their loading is very low, and they can be anchored, I think, with the steel beams if they are properly designed.
Thank you. And apologies in advance if I pronounce this incorrectly, but this has come through from Evan. Thoughts about Zigo?
Okay. Okay. So yeah, Zago, I think, is a product. It's actually the precast panels, I think, precast and concrete panels. So yeah, I think there is one benefit, there is one, I think, drawback with masonry is that it cannot be precast, and panels cannot be transported that easily because it is a discrete material because it has blocks and mortar layers, so which make it vulnerable to support um, uh, transporting from the factories to the sites. However, recently some research is going on to develop reinforced concrete masonry panels in which are very similar to Zago. So Zago is like concrete panels, no masonry, just the concrete, plain concrete panels. So on similar ways, people are thinking that we can make concrete masonry precast panels, but they have to be reinforced so that their robustness will be high, and then they can be transported from factories to the sites. So work is being done, but not like Zago. We don't have any ready-made product as yet for masonry, which can be set precast and which can be used as is from the factory on the site.
Thank you. And thank you to Ching Chai for your patience. You've asked this question a couple of times. And the question is, can the grout strength be increased to 50 MPa to increase compression capacity?
Yeah, that's a very good question. So, um, uh, actually, Australian Masonry Standards AS 3700 revised recently in 2018, and for that revision, a very comprehensive experimental campaign was run at QUT. So we tested around 130 walls, I think, and we tested different grout strengths to see their impact on the masonry compressive strength, and we varied the grout strength from 25 to 50 megapascal. So yes, I would say 50 megapascal strength can be used. However, I would like to add that Concrete Masonry Association of Australia, they restrict the grout strength to 50. So 50 megapascal is a upper cap for grout strength to be used in concrete block masonry.
Thank you. Thank you. And we are quickly running out of time, but we've time for a couple more questions. And one's coming from Oliver. Oliver's asking, how do we ensure that effervescence is not an issue on buildings, especially where blocks are used architecturally on a facade, or maybe where abutting wet areas?
Oh, yeah, that's a big problem with masonry. So this is because of the salt attacks and environmental issues. So I touch up a little bit on the durability issues in my presentation. So basically, to avoid this kind of effervescence on the surface of blocks, so I think initial designing is important in this case. So one has to select the blocks according to the environmental conditions of that area. And for new buildings, of course, then I think if the environment is severe, then the blocks should be tested to check the salt resistance. Otherwise, they can be cleaned, and then the coatings can be used to protect the surfaces from this kind of reaction, which happened because of the salt attacks.
Thank you, Tathea. We have a question that's come in from Les, who's watching from New South Wales. Good evening, Les. Asking, what is the current design advice on the most efficient structural system for lateral support of breeze blocks?
Oh, yeah, that's a good question. So, yeah, I touch upon some design specifications for breeze blocks as facades in my presentation. However, yeah, just to summarize, so breeze blocks, at the moment, the breeze blocks which are available in the market, they don't have provisions to be reinforced. So as I said earlier in my presentation, without reinforcement, these blocks have lower strength to the wind resistance and earthquake resistance. So I would advise that the breeze block panels should be secured from all four sides in by the supporting frame, whether it's made of concrete beam or column or masonry beam or column, or it can be a steel frame all around the breeze block frames, so to secure them against the wind and earthquake loadings. In housing, however, a 1 or 2 story house, it shouldn't be a problem because the wind loads and earthquake loads are much lower. And then the breeze blocks, I have shown some examples, they can be supported on top and bottom only, and they can resist the loading from environment and wind and earthquake. So I think for high rise and medium rise buildings, they have to be supported on all four sides through steel or concrete or masonry frames, actually.
So thank you for that. And we will make this our final question, and it's from Engineers Australia. And, we're in the middle of this huge building boom. Tonight we've been talking about masonry and breeze blocks. As we struggle to fill the demand at the moment, what do you see in the future in this area going forward?
Um, Yeah, so actually, I am actively researching in this area, specifically block masonry, and I believe that block masonry has huge potential in future buildings. And through these presentations and by doing research and by publishing papers, we are showing that the block masonry can be equivalent to concrete, reinforced concrete walls for resisting earthquake and wind pressures. So I think, and the benefit of using concrete block masonry is that it does not require any formwork. So I think it has huge potential in comparison to reinforced concrete, specifically. I will not talk about steel because steel, but in comparison, steel is strong, but it's expensive. um, it does not require formwork. So there are some pluses and minuses, but as compared to concrete, reinforced concrete walls, masonry walls with reinforcement and with blocks can achieve the same resistance which one can expect for high rise buildings or medium rise buildings. And the benefit is that concrete blocks are more resilient to fire, and they can be reinforced without formwork, so they would be cheaper as compared to reinforced concrete. So I think there is a huge potential for this product to be used for for future buildings and current buildings.
Thank you, Tathea. That's all we have time for today. I'm sure you'll all join me in thanking Dr. Tathea Zara for a brilliant presentation and for fielding the volume of questions on her own this evening. So a huge thank you from us all. I'd also like to take the time to thank Engineers Australia industry partner Austral Masonry for making tonight's webinar possible. For more webinars in the Engineer Speaker Series, please follow the YouTube link in the description box below. Don't forget to register also for the upcoming Large Scale Retaining Walls webinar on March 31st, and the link is in the description box below. As always, at Engineers Australia, we're on a continuous improvement journey, and we would appreciate all feedback on the program today. Please complete the short feedback form, which is linked in the description box below. Thank you again for joining us, and we hope to see you at our next webinar and have a lovely evening. Thank you.